Have you ever looked up at the moon
Right.
and it feels like you're seeing this old friend, a face you've known, well, forever?
Huh.
But have you ever stopped to think about the stories etched into that familiar face? We all see the craters, the dark splotches.
Hmm.
But what if those weren't just random dents and stains? What if they were chapters in a cosmic biography?
That's a really intriguing way to think about it. It's easy to take the moon for granted, isn't it? But its surface is just this incredible record of billions of years of history.
Exactly. And today we're going on a bit of a lunar field trip, all from the comfort of, well, wherever you're listening, our guidebook, the Atlas of the Moon. Think of it as our super detailed annotated map. We're going to zero in on some specific spots up there and try to understand the who, what, and why behind these, prominent features. It's not just about naming craters, it's about getting a glimpse into the epic saga written on that silvery surface.
And the Atlas of the Moon by Ruckel and Saronic is fantastic for that. It's not just pretty pictures, right? It gives us context, tells us about the names, and even hints at the best times to see these features. Really useful stuff.
Right. So, our mission today is to go beyond just seeing the moon to actually understanding some of its most fascinating landmarks. We want to pick out the details that make you go, huh, that's cool, and give you a deeper appreciation for our lunar neighbor. Ready for our first stop on the moon?
Absolutely. Lead the way. Where does our lunar journey begin?
Let's start with the big one, something you can even pick out with binoculars, actually.
Very good.
Crater Plato. It's on map 3, column 24 in our trusty atlas.
Ah, Plato. A classic for a reason. What really jumps out is that dark floor, doesn't it? It's quite striking. The atlas tells us it's a hefty 101 kilometers across and about a kilometer deep on average. That's a serious hole in the ground, or should I say, in the moon.
A kilometer deep?
Hmm.
Wow. Imagine dropping, I don't know, a skyscraper in there. It'd still have room to spare. And the atlas mentions this smooth floor with little tiny craters, craterlets they call them, but no big central peak. That always struck me as odd.
Yeah.
Most big impact craters have that sort of bounce back thing in the middle, don't they?
That's a key observation, yeah. The absence of a central peak in Plato, combined with that smooth, dark floor, well, it strongly suggests a later event in its history, a flood of what we call basaltic lava. Think of basaltic lava as like dark, dense, volcanic rock, a bit like you find in Hawaii or Iceland. This lava would have just poured in, filled the crater, and buried any central peak that might have formed initially. This likely happened during a period of significant volcanic activity on the moon, giving us a peek into its early geological life.
So it's like this crater got formed in some huge cosmic collision, and then later the moon was like, needs more lava, and just poured it in, almost like self-paving. And the atlas even gives us the sunrise and sunset times for Plato. Sunrise about 2.5 days after the first quarter, and sunset about half a day after the last quarter. That's pretty specific lunar real estate info.
It is, isn't it? Those timings tell observers when the sunlight hits Plato at just the right angle. Low angle sunlight is key. It creates these long shadows, making subtle details on the floor and the rim really, pop. Makes them much easier to see.
And of course, it's named after the Greek philosopher Plato. It makes you wonder, beyond just the name, just having these philosophical heavyweights like Plato and, as we'll see, Aristotle up there, does that tell us anything? Anything about how we've historically thought about the cosmos and maybe our place in it?
That's a fantastic question. It really speaks to our long-standing tradition, I think, of connecting earthly knowledge and, well, wisdom with the celestial realm. These names are a way of anchoring our understanding of the cosmos to our own intellectual history, making it feel a bit more familiar, perhaps.
Interesting point. Okay, from one iconic feature to another, let's jump to one of those seas you mentioned earlier. Mare Imbrium, the Sea of Showers. This thing is so big it spills across several maps in the atlas. It's huge.
Mare Imbrium is truly a giant on the near side of the moon. I mean, it's one of the most obvious features. If we think about the big picture of lunar history, it's believed to have formed from an absolutely massive impact very early in the moon's life. Imagine something maybe the size of a small asteroid just slamming into the young moon. The crater it left was just
A
enormous.
truly cataclysmic event. And then, like with Plato, but on a much grander scale, it got filled in later with that basaltic lava, right? That's why it's one of those big, dark, relatively smooth areas we see so clearly.
Precisely. The smoothness of Mare Imbrium is a direct result of those subsequent lava flows. They just covered up the rough, jumbled terrain left by that initial colossal impact. Compared to the heavily cratered highlands, which look much older and more battered, the Maria have a much calmer appearance, geologically speaking.
Calm after the cosmic storm. That's a good way to put it. The Alice mentions that Mare Imbrium has some interesting stuff around its edges, like the Apennine Mountains. They sound pretty impressive.
They certainly are. The Apennine Mountains form a significant chunk of the rim of the Imbrium Basin. So what you're seeing there are basically the fractured and uplifted remnants of the edge of that impact event, frozen in time. It really drives home just how immense that ancient collision must have been. The energy involved is just staggering.
It's just mind-boggling to think about the scale. A whole sea carved out by violence in space, now bordered by mountains taller than many we have on Earth. Wow. Okay, let's shift gears a bit. Let's look at a crater with a totally different vibe. Crater Tycho, way down on map 64, column 168. This one's got those crazy bright streaks radiating out from it. You can't miss it near full moon.
Ah, Tycho. It's a very different kind of feature compared to Plato or the Maria. What's really fascinating about Tycho is its youth. It's a relatively young impact crater, geologically speaking, and that's why it has such a prominent bright ray system.
Those bright lines that look like someone took a celestial paintbrush and just flick white paint all over the moon.
Yeah.
The atlas says it's about 85 kilometers across and seriously deep, almost 5 kilometers. That's like digging a hole from sea level nearly to the top of Mount Kilimanjaro, but, on the moon.
It's a significant depth indeed. And those bright rays, they're made up of ejected material, pulverized rock and dust, basically debris that was thrown out with incredible force when the impact that formed Tycho occurred. Because it's a young crater, this ejected material hasn't had as much time to be darkened by space weathering. Things like the constant bombardment of tiny space rocks, micrometeoroids, and the effects of the solar wind. It's still fresh, relatively speaking.
So it's like seeing the fresh splash marks from a cosmic pebble dropped into the lunar pond. That's a cool image. The atlas also mentions it has a central peak complex and terraced inner walls. That sounds like a pretty dramatic landscape if you were standing inside it. Terraced inner walls? What exactly does that mean?
Think of the sides of a landslide settling in steps. That's a bit like how terraced walls form in a large crater. It happens as the material slumps downward and adjusts gravitationally after the impact shock waves pass. And the central peak, or peak complex in Tycho's case, that's the rebound of the lunar surface after the initial compression from the impact, a sort of geological bounce back. For observing Tycho and those amazing rays, the atlas notes sunrise is about 1 day after the first quarter, and sunset about 1 day after the last quarter. Ideal lighting conditions.
Perfect timing to catch those rays in the sunlight. It really makes you think about the sheer energy involved, an impact that could blast material hundreds, even thousands of kilometers across the moon. Incredible power. Okay, for something a bit different now, let's look at rille Hyginus on map 34, column 94. It's called a prominent linear rille. What exactly is a rille? Is it like a crack?
A rille is essentially a groove or trench on the moon's surface. Yeah. Think of it like a lunar channel or valley. Rille Hyginus is particularly interesting because the atlas notes it's a shallow valley, and it seems to have been formed, at least in part, by a chain of smaller craters along its length. It stretches for an impressive 220 kilometers. It's quite long.
A chain of craters making a valley. That's a different way to sculpt the lunar landscape, isn't it? So it wasn't just one big event that carved this out, like an impact.
The prevailing idea is that Rima hyginus likely formed due to internal stresses in the moon's crust, something we might call volcanic or tectonic activity. Basically, the ground stretched and cracked open. The line of craters along it could be evidence of vents where lava or gas escaped, or perhaps just collapses along that fracture line. It's not perfectly understood, but definitely internal forces at play.
So, like the moon having its own little version of a rift valley, maybe,
Ugh.
but formed in a slightly different way. The atlas mentions it's an interesting feature to look at through a telescope. I can just imagine tracing that long, straightish groove across the surface.
It offers a different kind of visual interest compared to the round craters, definitely. It reminds us that the moon wasn't just, passively bombarded. It also had its own internal geological processes at work, even if impact events are more obvious today.
Good point. Okay, we've seen a sea, a phosphorus crater, a rayed youngster, and a groove. Now let's aim high. Let's talk about the Montes Apenninus, the Apennine Mountains on map 22, column 70. These form part of the rim of Mare Imbrium, so they must be tied to that giant impact we talked about earlier, right?
Absolutely. As we discussed, the Apennines are a direct consequence of the Imbrium impact. You can't separate them. The sheer force of that event not only created a basin, but also pushed up and fractured the surrounding lunar crust, creating these, majestic mountain peaks along the edge.
And majestic they sound. The atlas's individual peaks reach heights of 2,400 to 5,000 meters, 5 kilometers high on the moon. That's taller than a lot of mountains here on Earth. The highest point mentioned is Mount Hadley Delta.
It really puts the scale of these lunar events into perspective, doesn't it? To think of mountain ranges rivaling terrestrial ones being formed almost instantaneously by an impact on another world billions of years ago, it just underscores the immense power at play in the early solar system. It was a violent place.
It truly does. It's like looking at the rim of a giant scar, but the scar tissue is a mountain range. All right, last but certainly not least, for our quick tour, let's visit Crater Aristoteles on map 5, column 7. Another philosophical heavyweight joining Plato in the sky.
Indeed, Aristoteles is another large complex crater, and it's interesting to compare it to Plato, not just because of the philosophical connection. The atlas describes it as having terraced inner walls and a relatively flat floor, but with some irregularities and, importantly, a small central mountain or peak.
Uh-huh. So unlike Plato, Aristoteles does have that central peak. What does that tell us about his history compared to Plato?
Right. The presence of a central peak in Aristoteles, in contrast to Plato's smooth, lava-filled floor, suggests that Aristoteles didn't experience the same extensive lava flooding that Plato did, or at least not enough to bury the peak. The central peak is a typical feature of large impact craters, formed by that rebound of the lunar crust after the impact energy dissipates. The terrace inner walls, similar to what we saw in Tycho, indicate that the crater walls have slumped and adjusted over time since its formation. Standard stuff for a big crater. So while both are large impact craters, their post-formation geological histories seem to have diverged. One got flooded, one didn't as much.
That's like they had different afterlives after they were created by these huge impacts. Fascinating comparison. And the sunrise and sunset times for Aristoteles are about 1.5 days after the first quarter and 1.5 days before the last quarter.
Again, those timings are invaluable for lunar observers wanting to see the crater under the most revealing light, picking out those terraces and the central peak.
It's just incredible how much history and detail is etched onto the moon's surface, isn't it? And how much we can learn just by looking closely with a good guide like our atlas.
Absolutely. The moon's surface is, it's a remarkable museum of cosmic events, each feature telling a story of impacts, volcanic activity, and the slow processes of space weathering over billions of years. And as you mentioned, the names we've given these features connect our scientific exploration to our broader cultural and intellectual heritage. It bridges worlds in a way.
It really does. And the amazing thing is you don't need like super fancy equipment to start exploring this stuff. Even with a basic pair of binoculars, you can pick out some of these features we've talked about and start to piece together this incredible story yourself. It's like having a window into the deep past right there in your own backyard.
Precisely. The Atlas of the Moon isn't just a reference book, it's really an invitation to become a lunar detective yourself, to go out and look.
So the next time you glance up at the moon, maybe tonight, remember it's not just a static, pale orb hanging there. It's a dynamic, ancient world with a rich history written all over its face. We've only just touched on a few of the stories the Atlas of the Moon could help you uncover. There's so much more. What really stands out to you about these lunar landmarks we've explored today? Does the sheer scale of Mare Imbrium inspire a sense of awe? Does the intricate detail of Tycho's rays spark your curiosity about its violent birth? Or maybe the pairing of Plato and Aristoteles gets you thinking about our place in the cosmos. Grab an atlas, or even just look up information online. Take a look through binoculars if you have them, and you might be surprised by the lunar tales waiting to be discovered. It definitely makes our old friend in the night sky feel a whole lot less distant and a whole lot more fascinating, right?